we'll do in class together. If you can do number 2, you can do all the way up through number 5. They're all modeled exactly the same. So this is a distance, rate, time problem. And I'm going with the wind and against the wind. So when you're traveling with the wind, you're going faster. When you're traveling against the wind, you're going slower. So R would be your rate with no wind, or your rate in still air. So traveling against the wind, Sappy can go 30 miles. She can cover a distance of 30 miles against the wind. When she's traveling with the wind, she can cover further ground. She can go 66 miles. The rate of the wind is 3 miles per hour. So her rate with the wind is R plus 3. Her rate against the wind is R minus 3. So the time column. Time here, I would think of time as distance over R. Just take the basic relationship and solve it for T. So her time would be a distance of 66 over a rate R minus 3. Now, the fact that the time is the same regardless of the rate of the wind, then the same amount of time she can cover these two distances. That tells you how to set up your relationship for the equation. And now simply use cross products to solve for R. And the R that you get would be her rate in still air. So in order to answer the question, you would have to either add 3 or subtract 3. Now, 3, 4, and 5 are exactly like this. So I'm going to ask you to complete this as well as do up through number 5. Okay, let's look at number 6 together. Another distance, rate, time problem. So your basic relationship, distance equals rate times time. And this is Jonathan going up and down a mountain trail, taking the same route. So his distance both times is 15. I'm going to let the up portion of the trip just be my plain relationship with distance, rate, and time. I'm going to let his rate up be R, and then his time up, I will consider his time up as distance covered over rate, D over R. Coming down, his return trip along the same trail took 30 minutes less, so his time is minus 1/2. And he was able to increase his speed by 1, so his rate becomes R plus 1, comparing to the up portion. So looking at the down descriptions, I have too many variables. So if I go back to the up row and I think of this relationship time equals 15 over R, I'm comparing his time down to his time up. So if I replace the T and the time down with the expression 15 over R, I now have a down portion of the trip all described with the variable R. So to set up my relationship for solving, I have my rate of R plus 1 times my time of 15 over R minus 1/2, and that equals a distance of 15 kilometers. So this problem looks a little bit unlike anything we've done because now we're going to do the binomial multiplication on this. And I'm going to go ahead and present the answer, and if it's a little bit confusing, you need to sit and stop the tape and figure it out slowly for yourself. But I'm going to multiply R times 15 over R, the end result being 15, and I'm going to do that type of multiplication. R times negative 1/2 Okay, so that's step number 1, getting rid of the parentheses. And then a little bit of analysis. If I subtract 15 from both sides, then that's gone. And then what's left over? Now I'm going to use the LCD method to eliminate the denominator. And the least common denominator here would be 2R. So when I multiply each expression by 2R over 1, This is what remains. And then rearranging this into something factorable, and then factoring it. And you can also use the quadratic formula. And you can see that one of the roots would not be an option. That can't be an option. And r equals 5. So that means the rate going up is 5. The rate coming down is 6. And how long does it take him to climb up and down the mountain? I will let you go ahead and make those substitutions into the problem. Looking at the time piece, if r is 5, 15 over 5 is 3, and I will let you take this portion and clean it up. Number 7 is exactly the same. And then the next problem, number 8, I'll set up for you. Okay, the cost of a bus trip was $180. The people who signed up for the trip agreed to split the cost equally. However, 6 people did not show up, so that those who did had to pay more money. How many people actually went on the trip? So I have my columns set up, or my rows set up as original signups and the people who, then the number who actually showed up. The cost of the trip, though, is the same regardless of how many people show up. So the cost of the trip is $180 regardless. So let's let X represent the people who originally signed up. So that means that the cost per person is the total trip divided by the number of people that are going. Now, what actually happened, 6 fewer people showed up. So that's X minus 6. And then the cost increased. So the original cost of $180 over X increased by $1.50. So the number of people going times the cost per person has to equal the total cost. So this will be set up. I'm going to use the actually showed up column, or row rather, and then I'm going to have to use the same math skills as I used in the problem with Jonathan going up and down the hill. And you can always use the quadratic formula when you get to a point of factoring. And I will tell you that at the end of this, I'm going to ask you to take it from here. X equals 30. So that means that 24 people actually went on the trip. So I'm going to ask you to take that problem and clean it up at that point. And then I would like for you to apply the same logic to the next problem. It's exactly the same type of problem.